In question 1, we're asked to find this integral here, giving our answer in its simplest form. Well, I will start by writing the integral in index form. So we're looking at the integral of 2x to the power of a half over x squared minus 3 over x squared with respect to x, which simplifies to the integral of 2x to the minus 3 over 2 minus 3x to the minus 2 dx. Now that I've got the expression to be integrated in index form, I can proceed with integration. And in integration, we increase the power by 1 and we divide by the new power. So we're looking at 2 times x to the minus a half over minus 1 over 2. And then we've got minus 3 x to the minus 1 over minus 1 plus the constant of integration c. And I need to simplify my answer, which gives me negative 4x to the minus a half plus 3x to the minus 1 plus c. In question 2, we need to show all stages of the working, and solutions relying entirely on calculator technology are not acceptable. So we need to be careful here to show all of our working clearly. So we've got f of x here, a cubic polynomial in x, a, b are constants. We are told that x minus 4 is a factor of f of x, and we need to use the factor theorem to show that 10a is equal to 32 plus b. Well, the factor theorem states that if x minus alpha is a factor, then f of alpha is 0, and in our case the alpha is the 4, so we know that f of 4 must be 0. So let's evaluate f of 4, which is equal to 2 times 4 to the power of 3 minus 3a times 4 to the power of 2 plus b times 4 plus 8a. This simplifies to 128 minus 48a plus 4b plus 8a, which further simplifies into 128 minus 40a plus 4b. Well, we know that this must be equal to 0, and therefore we've got 128 plus 4b being equal to 40a. I will divide throughout by 4 to get 32 plus b is equal to 10a as required. Now, given also that x minus 2 is a factor of f of x, we need to express f of x in this form here, where k is a constant to be found. Well, let's use the fact that x minus 2 is a factor again with the factor theorem to find the values of a and b. So f of 2 must be 0, and f of 2 is equal to 2 times 2 to the power of 3 minus 3a times 2 to the power of 2 plus b times 2 plus 8a. This simplifies to 16 minus 12a plus 2b plus 8a, which further simplifies to 16 minus 4a plus 2b, which must be equal to 0 because x minus 2 is a factor. So we're looking at 16 plus 2b being equal to 4a. I will divide throughout by 2 to get 8 plus b is equal to 2a, which leads to b being equal to 2a minus 8. And all I'm facing here is simultaneous equations in a and b. We have one equation involving a and b here, and we have established here the first equation involving a and b. So I'll be substituting b into the first equation we obtained in part a. So we are looking at 32 plus the b, which is 2a minus 8, being equal to 10a, and therefore we've got 24 is equal to 8a, and therefore 3 is equal to a. And I will proceed in finding b. b is 2a, so 2 times 3 minus 8, which is equal to negative 2. And now that I've got a and b, let's go and look at the expression for f of x. Well, f of x was equal to 2x cubed minus 3 times a, which is 3x squared, plus the b, which is negative 2x, plus 8 times a, so 8 times 3. So we're looking at 2x cubed minus 9x squared minus 2x plus 24 for f of x. Now remember, we're trying to arrive at f of x in this factorized form here, we already know two of the factors. We know that x minus 2 is a factor and x minus 4 is a factor. So if I was to factorize this cubic, I would expect 3 brackets. I already know two of the brackets, so I've got x minus 2 times x minus 4, and I'm missing the third bracket. Well, obviously x times x is x squared, and for me to get the leading term of 2x cubed, I certainly need this term to be 2x, and then to get the 24, the constant term, I've got negative 2 times negative 4, which is 8, so times 3 to give me the 24, so I'm missing the 3 here, which must be the factorized form for f of x, and therefore we conclude that k is equal to 3. In part C, we're asked to state the number of real roots of the equation f of x is 0 and write down the largest root of the equation f of a third x is equal to 0. Now for the first part of f of x is 0, using the factorized form here, we can see that we've got x minus 2 being 0, or we have x minus 4 being 0, or we've got 2x plus 3 being equal to 0. So we've got x is 2, or x is 4, or 2x is negative 3, which means that x is negative 3 over 2, and therefore we can see that we've got a total of 3 real roots for the given cubic polynomial. There was no need for me to find the roots. I could simply see that I've got 3 distinct linear factors giving rise to 3 real roots. But I will need the actual roots to answer the second part here, which says write down the largest root of the equation f of a third x is 0. Now we're looking at the transformation. The third x here simply means we need to multiply x by 3. So the largest root was x is 4. If I multiply 4 by 3, I get an answer of 12. So the largest root to the equation is x is equal to 12. Question 3 is on vectors. We've got the position vector of point P and point Q. We need to find the vector PQ. So the vector PQ is simply going to be the position vector of Q. So OQ minus OP. We know it's always the second letter minus the first letter. So we're looking at 3i minus 5j minus the 9i minus 8j. So 3i minus 9i will give me negative 6i, and then negative 5j minus the negative 8j will give me plus 3j. So the vector PQ is negative 6i plus 3j. We then have the point R such that the vector QR is 9i plus 18j, and we need to show that the angle PQR is 90 degrees. I will start by writing down that the vector QP is simply equal to 6i minus 3j. So I'm just flipping the signs in the vector for PQ. And then I'm going to draw a diagram to see exactly what's happening. We've got the vector QR, which goes 9 to the right and 18 up. And then we've got the vector QP, which goes 6 to the right and 3 down. I'll be working with gradients to show that this angle here is a 90-degree angle. So we will start with the gradient of QR, which is simply given by 18 over 9, which is equal to 2. And then the gradient of QP, which is equal to negative 3 over 6, which is equal to minus a half. Now we observe that the gradient of QR times the gradient of QP gives a result of negative 1. And therefore we conclude that QR is perpendicular to QP, which simply means that PQR is 90 degrees. Now an alternative approach would be to join R with P and therefore consider the triangle QPR and investigate whether Pythagoras holds true. So I will start by finding the magnitude of QR. So this is simply given by doing 9 squared plus 18 squared and all square rooted. This gives an answer of 9 root 5. And then I will proceed with the magnitude of QP. This is equal to minus 6 all squared plus 3 squared and all square rooted. This gives an answer of 3 root 5. And then I will proceed in finding the vector PR. So to go from P to R, I can go from P to Q and then from Q to R. Now the vector PQ is negative 6i plus 3j, whereas the vector QR is 9i plus 18j. Well, negative 6i plus 9i is 3i, and then 3j plus 18j gives me 21j, and I can proceed in finding the magnitude of PR. So PR, the magnitude of this, will be equal to 3 squared plus 21 squared and all square rooted. This gives an answer of 15 root 2, and we observe that 15 root 2 raised to the power of 2, this is the hypotenuse of the triangle, which gives an answer of 450. And at the same time, if I consider QR squared and QP squared, we're looking at 9 root 5 squared plus 3 root 5 squared, which also gives an answer of 450. And therefore we conclude that Pythagoras' theorem holds true in the triangle PQR, which simply means that the angle PQR is 90 degrees. In part C, we are also given that the point S is such that the vector PS is 3 times the vector QR, and we need to find the exact area of PQRS. So this is what we had up to now. We had QR and QP. Now the vector PS is 3 times the vector QR, so PS is parallel to QR and has a length which is 3 times the length of QR, so it must be something like this. So I can join R and S together, so PQRS is a trapezium. We've got right angles here and here, so this is the area we're trying to find. We know that the distance QP is 3 root 5, the distance QR is 9 root 5, and the distance PS must be 3 times the 9 root 5, which is 27 root 5. So we're trying to find the area of PQRS, which is simply a trapezium. So I'll be doing base 1, which is 9 root 5, plus base 2, which is 27 root 5 over 2, times the height of the trapezium, which is 3 root 5. If I plug this on the calculator, I get an answer of 270 squared units for the area of the trapezium. In question 4, we're given a sketch of triangle ABD and triangle BCD. We've got different measurements here. We are asked to show that x is 10.5, correct to 3 significant figures. So I'll be concentrating on triangle BCD here, and I will be applying the sine rule, which says that sine A over A is sine B over B. So in our case, it's going to be sine of 140 over x plus 3 being equal to sine of 30 over x, and I'll be solving for x. So let me write this down. We've got sine of 140 over x plus 3 is equal to sine of 30 over x. I will proceed by cross multiplying. So we've got x sine of 140 being equal to sine of 30 times x plus 3. I'm not rushing on the calculator yet. I will be expanding the right hand side. So we're looking at x sine of 140 being equal to x sine 30 plus 3 sine 30. I will be collecting the x terms on the left hand side, giving me x sine of 140 minus x sine 30 is equal to 3 sine 30, and I will factor out the x on the left hand side to give me x brackets sine of 140 minus sine of 30 is equal to 3 sine 30, which means that x is given by 3 sine of 30 and all divided by sine of 140 minus sine of 30. Now if I plug this on the calculator, I get that x is 10.505 ... which correct to 3 significant figures is 10.5 as required. Now given also that AD is x minus 2 centimeters, we need to find the length of AB, giving our answer to 3 significant figures. So I'll be concentrating on the triangle ABD. The angle ADB here is 150 degrees. So I'll be using the cosine rule on the highlighted triangle here. So first of all, we know that AD is x minus 2. We know that x is 10.505 dot dot dot, and deducting 2 will give me 8.505, whereas we've got BD being equal to x plus 3, which is 10.505 plus 3, which gives an answer of 13.505, and I can proceed with the cosine rule. We know that AB squared will be given by AD squared, so 8.505 squared, plus BD squared, so 13.505 squared, minus 2 times the AD, so the 8.505, times the BD, the 13.505, times the cosine of the included angle, so cos of 150. Well, if I plug this on the calculator, I get that AB squared is 453.6727 dot dot dot. And therefore, if I proceed by taking the square root, we get that AB is 21.3 centimeters to 3 significant figures. In question 5, we've got the curve C1 with equation y is 6 over x plus 3, and we are asked to sketch the curve stating the coordinates of any points where we cut the axis, as well as state the equations of any asymptotes to the curve. Well, let me start with the asymptotes. We know that we're looking at a reciprocal curve because x appears in the denominator, and obviously we've got a vertical and a horizontal asymptote. Well, the vertical asymptote has equation x is 0 because when x is 0, we're dividing by 0, and this leads to an undefined result. And for the horizontal asymptote, I'll be considering y as x grows larger and larger. So as x goes to infinity, 6 over x goes to 0, and therefore y tends to 3, which means that the equation of the horizontal asymptote is y is equal to 3. Now for the horizontal asymptote, an alternative approach would be to go on my calculator. I'm going to be substituting a really big value on my answer key, and then I'll be doing 6 over ans plus 3. So essentially I'm simulating the process of x growing very large. I press the equal sign. I see the 3 here. So the equation of the horizontal asymptote is indeed y is equal to 3. I will then proceed in finding the cut on the x-axis, which means that y is equal to 0. So when y is equal to 0, we're looking at 0 being equal to 6 over x plus 3. So we're looking at negative 3 is 6 over x. I will cross multiply to get negative 3x is equal to 6, and therefore x is negative 2 is the cut on the x-axis, which means I can proceed into sketching the graph. So we've got the axis, we've got the vertical asymptote with equation x is 0, it's the y-axis. We've got the horizontal asymptote with equation y is equal to 3, and the graph looks something like this, cutting the x-axis at negative 2. In part B, we are given a second curve C2 with this equation here. It's a quadratic, and we need to show that C1 and C2 intersect when this cubic equation is equal to 0. So if the two curves intersect, I can set them equal. So we're looking at 3x squared minus 4x minus 10, which is the equation for C2, being equal to 6 over x plus 3, which is the equation for C1. I will multiply throughout by x to get rid of the denominator of x. So we're looking at 3x cubed minus 4x squared minus 10x being equal to 6 plus 3x. And I will be collecting everything on the left-hand side to get 3x cubed minus 4x squared minus 13x minus 6 is 0 as required. Now, given that the x-coordinate of one of the points of intersection is negative 2 over 3, we need to use algebra to find the x-coordinates of the other points of intersection between the two curves, and solutions relying on calculator technology here are not acceptable, so I cannot just plug in the cubic on my calculator and get the answers. So what I'll be doing here, I'll be using the factor theorem, which says that if x minus alpha is a factor, then f of alpha is 0. I will introduce f of x, so I will say f of x is the cubic equation we obtained in part B. So this is 3x cubed minus the 4x squared minus the 13x minus 6. And we know that f of negative 2 over 3 is equal to 0. And therefore, using the factor theorem, we know that this means that x plus 2 over 3 must be a factor of f of x. And I can actually proceed. If I multiply this by 3 to get rid of the denominator, this simply means that 3x plus 2 is also a factor of f of x, and this will give me the key to proceed with long division and therefore break down the cubic into the product of a linear and a quadratic, which will allow me to proceed in solving the equation. So let's proceed with the long division. We are always trying to match the highest order term found on the left hand side. So 3x here will be multiplied by x squared to give me 3x cubed plus 2x squared, and then we deduct. So the 3x cubed terms will cancel out, and I've got a negative 4x squared minus the 2x squared to give me negative 6x squared minus the 13x minus 6. I will multiply then by negative 2x to get negative 6x squared minus 4x, and I will deduct once more to get negative 9x minus 6. So I need a negative 3 here to give me negative 9x minus 6, which of course leaves me with a remainder of 0. And this means we can write f of x as a product of 3x plus 2 and x squared minus 2x minus 3. And I can actually proceed into further factorizing this into 3x plus 2 times x minus 3 and x plus 1. Now we know that if f of x is equal to 0, then this means that either 3x plus 2 is 0, or x minus 3 is 0, or x plus 1 is 0. So we've got a total of 3 solutions. So we're looking at 3x is negative 2. So x is negative 2 over 3, which is the solution we were given by the question at the beginning, or x is 3, or x is negative 1. And therefore we conclude that the other 2 points of intersection are at x is 3 and the second one at x being negative 1. Question 6 on the binomial expansion. We've got 1 plus ax raised to the power of 12, and we are told that the expansion up to the term in x squared is given by 1 minus 15 over 2x plus kx squared, where a and k are constants. Well, in part A, we need to show that a is negative 5 over 8, and I will start by obtaining the first 3 terms in the expansion of 1 plus ax raised to the power of 12. So we start with 1 to the power of 12 plus 12, choose 1, times 1 to the power of 11 times ax, plus 12, choose 2, times 1 to the power of 10 times ax to the power of 2 plus dot dot dot. As always, notice that the sum of the 2 powers is always giving me the original power of 12, and I can proceed in simplifying. We've got 1 plus 12ax plus 66a squared x squared plus dot dot dot. Now we compare the expansion we just obtained with the expansion given in the question. I can equate the x term, so we get the minus 15 over 2 is equal to 12a. So let me write this down. We've got 12a being equal to negative 15 over 2. Now we'll divide both sides by 12, and I get that a is equal to negative 5 over 8 as required. In part B, we're asked to hence find the value of k. Well, k is the coefficient of x squared, which is 66a squared. So we've got k is equal to 66a squared, which is equal to 66 times the negative 5 over 8 raised to the power of 2. And this gives an answer of 825 over 32. This is the value of k, the coefficient of x squared, in the expansion. We're then asked to use the expansion and make our method clear to find an estimate for the value of 17 over 16 raised to the power of 12, giving our answer to 4 decimal places. So we're looking at 1 minus 5 over 8x raised to the power of 12 to be equal to 17 over 16 raised to the power of 12. the first thing to do is determine the value of x. That will make the left hand side be 17 over 16 to the power of 12. I will start by cancelling out the powers of 12. So we're looking at 1 minus 17 over 16 being equal to 5 over 8x. So we're looking at minus 1 over 16 is 5 over 8x. I will cross multiply, you get negative 8 is equal to 80x, and therefore x is negative 0.1. This is the value of x that I can substitute into my expansion to get an estimate for 17 over 16 raised to the power of 12. So what we are looking at is that 17 over 16 raised to the power of 12 will be approximately 1 minus 15 over 2 times the x, which is negative 0.1, plus the 825 over 32 times the negative 0.1 squared. So let me go on my calculator. I'm going to press negative 0.1. I press the equal sign. I have just stored the value of x on my answer key. So we're looking at 1 minus 15 over 2 times the ans plus 825 over 32 times the ans to the power of 2. So they are expecting the answer to 4 decimal places. I'll press the SD button. So to 40 P's, we're looking at 2.0078. And if I want to check the validity of the answer, I can deduct from this the 17 over 16 to the power of 12. This will be the exact value of 17 over 16 to the power of 12. And if I'm correct, I expect to get a small number as my answer here. So I get negative 0.062, which is the difference between the estimate and the exact value. And therefore, the two are in close agreement. Question 7 is a modeling question. We've got a chimney emitting smoke particles, and on a particular day, the concentration of smoke particles in the air emitted by this chimney, capital P parts per million, is measured at various distances x kilometers from the chimney. Now we've got a sketch of the linear relationship between log of P and x, and the line passes through the point 0,3.3 and 6,2.1. And we need to find a complete equation for the model in the form capital P is AB to the x, with A and B being constants to be found to 4 significant figures. Well, I will start by finding the gradient of the straight line. So M, it's going to be 2.1 minus 3.3 over 6 minus 0. This gives an answer of negative 0.2, which is the gradient of the straight line. We've got the y-intercept, it's 3.3. We're not dealing with y and x, we're dealing with log of p base 10 and x. So the equation of the straight line will be log of p base 10 is equal to negative 0.2x plus 3.3. I will then take the model here. I'm going to take log of both sides. So we're looking at log of p base 10 is equal to log of ab to the x base 10. Now log of a times b to the x can be written as log of a base 10 plus log of b to the x base 10, which can be further written as log of p base 10 being equal to log of a base 10 plus x log of b base 10. And I can compare with the equation of the straight line here. So the constant term, the 3.3, is the log of a base 10, and the coefficient of x, the gradient here, the negative 0.2, is the log of b base 10. So we are looking at log of a base 10 is equal to 3.3, which means that a is 10 to the 3.3, which correct to 4 significant figures is 1995. And we also have log of b base 10 is equal to negative 0.2, which means that b is 10 to the negative 0.2, which gives an answer of 0.6310. And therefore the full equation of the model, which is needed to claim the final mark in this part of the question, is that capital P is 1995 times 0.6310 to the power of x. In part B, we need to interpret the value of A times B with reference to the model. So the model was that P is AB to the X, which was found to be 1995 times 0.6310 to the power of X. We observe that if I substitute X is 1, then we get that P is A times B to the power of 1, which is simply AB, which is 1995 times 0.6310, and this gives an answer of 1259. And therefore we conclude that at a distance of 1 kilometer from the chimney, the concentration of smoke particles in the air is 1259 parts per million. So the AB is simply the concentration of smoke particles when you're at a distance of 1 kilometer from the chimney. Be careful here, you need to mention smoke particles and parts per million in order to claim the mark. In question 8, we need to show all stages of our working, and solutions relying entirely on calculator technology are not acceptable. Well, we're given a sketch of the curve C, it's the cubic shown here. The line L is a tangent to C at the point A. We are told that the line L has equation y is negative 2x plus 7. And we need to use calculus, this means differentiation, to show that the x-coordinate of A is 2. So I will start by finding an expression for dy dx, and we know that when we differentiate, we multiply by the power and we deduct 1 from the power. So this is giving me 3x squared minus 14. And this is giving me the gradient of the curve, and we know that at the point A here, the gradient is negative 2, which is the gradient of the tangent here. So I will be equating dy dx with negative 2, taking me to 3x squared being equal to 12, and therefore x squared is equal to 4, which means that x is plus minus 2. However, looking at the sketch here, we can see that A is on the positive x-axis. So from the graph, we can see that at the point A, x is greater than 0, and therefore we conclude that x is 2. Now the line L cuts C again at the point B, and we need to verify that the x-coordinate of B is negative 4. So first of all, we know that at B, we've got the curve and the straight line meeting, so I'll be equating the two. So I'm going to say that at point B, we've got the cubic, which was x cubed minus 14x plus 23, being equal to the tangent, which was negative 2x plus 7. I will collect everything on the left hand side to get x cubed minus 12x plus 16 is 0. I'm not asked to solve the given cubic here. I'm asked to verify that the x-coordinate of B is negative 4. So I will simply check whether x is negative 4 verifies this equation here. So this means that we're looking at x cubed minus 12x plus 16, which is equal to negative 4 raised to the power of 3 minus 12 times negative 4 plus 16. If you plug this on the calculator, you get an answer of 0, and therefore we conclude that at the point B, x is negative 4. Now the finite region R, shown shaded here, is bounded by the curve C and the line L, and we need to use algebraic integration to show that the area of R is 108 units squared. So let me start by updating the diagram here. We've got the equation of the straight line and the equation of the curve. We have established that point B has coordinate x being negative 4 and point A has an x coordinate of 2. So to find the region here, it's the region enclosed above by the curve and below by the straight line. So I'll be using integration. My limits will be negative 4 and 2. And I'm doing curve above, which is x cubed minus 14x plus 23 minus the line below, which is the negative 2x plus 7. And we are integrating with respect to x. So we're looking at the integral from negative 4 up to 2 of x cubed minus 14x plus 23 plus 2x minus 7 dx, which further simplifies into the integral from negative 4 up to 2 of x cubed minus 12x plus 16 dx. Well, we know that in integration we increase the power by 1 and we divide by the new power. So we're looking at x to the power of 4 over 4 minus 12x squared over 2 plus 16x. My limits are negative 4 and 2. I will start by simplifying the 12 with the 2 to give me a 6 here, and I will substitute the upper limit. So we're looking at 2 to the power of 4 over 4 minus 6 times 2 to the power of 2 plus 16 times 2. And then for the lower limit, we've got negative 4 raised to the power of 4 over 4 minus 6 times negative 4 raised to the power of 2 plus 16 times negative 4. So if I evaluate the upper limit, I get an answer of 12 minus the lower limit, which gives me an answer of negative 96, which gives overall an answer of 108 as required. Question 9 is on logs. We are told that P is log of 16 base A and Q is log of 25 base A, where A is a constant, and we need to find in terms of P and or Q log of 256 base A. So starting with the log of 256 base A, we first observe that 256 is 16 squared. So we're looking at log of 16 squared base A, which is 2 log of 16 base A, and therefore this is equal to 2p. In part B, we're dealing with the log of 100 base A, and the first thing that comes to mind is splitting the 100 as being the product of 4 and 25. So it's a log of 4 times 25 base A. This allows me to split this into the log of 4 base A plus the log of 25 base A. And we know that 4 is the square root of 16. So this is log of 16 raised to the power of a half base A. And of course, log of 25 base A is simply Q. So I've got a plus Q here. So we're looking at a half log of 16 base A plus Q. Log of 16 base A is P. So this is simply a half P plus Q. In part C, we've got the log of 80 base A times log of 3.2 base A. And the first thing to do is write 80 as 16 times 5. So we have log of 16 times 5 base A times the log. Now the 3.2 is simply 16 over 5 as a fraction. So log of 16 over 5 base A. So I can write this as the log of 16 base A plus the log of 5 base A, and then I've got log of 16 base A minus log of 5 base A. Now log of 16 base A is simply P, so we've got P here, and we've got log of 5 base A. Well, I will write 5 as the square root of 25, or simply 25 to the power of a half. So we've got plus log of 25 to the power of a half base A. And similarly here, we've got P minus log of 25 to the half base A. Now the half can come down, so we're looking at P plus a half log of 25 base A times P minus a half log of 25 base A, which is of course P plus a half Q, the first bracket, times P minus a half Q. It's okay to stop here, or I can proceed in expanding. It's the difference of two squares, simplifying to P squared minus Q squared over 4. In question 10, we're given a sketch of the circle C. The point P with coordinates negative 1k plus 8 is the center of C. The point Q with coordinates 3k squared minus 2k lies on C. K is a positive constant, and the line L here is a tangent to C at Q with a gradient of negative 2. And we need to show that this leads to k squared minus 3k minus 10 is 0. Well, the first thing to do, as always, is update the diagram here with all the information provided up to now. So we've got the coordinates of P, the coordinates of Q. We know that the gradient of the straight line is negative 2, and I will join PQ together, which is the radius, and I know that the angle between the radius and the tangent is 90 degrees. So the idea is to find the gradient of PQ in terms of K, and then I can use the fact that if two lines are perpendicular, then their gradients multiplied to -1 to set up an equation in terms of k. So let's start with the gradient of PQ. So the gradient of PQ is given by k squared minus 2k minus the k plus 8 over the 3 minus the -1. This gives me k squared minus 2k minus k minus 8, and all of it divided by 4, which simplifies to k squared minus 3k minus 8 over 4. And knowing that the gradient of the tangent is -2, this means that the gradient of the radius, the gradient of PQ, must be a half. So this is equal to a half. I flip the gradient, I change the sign. I will proceed in cross multiplying. So we've got 2 brackets k squared minus 3k minus 8 being equal to 4. And of course, the 2 with the 4 will simplify to leave me with a 2 here. And therefore, we've got k squared minus 3k minus 8 is equal to 2. And if I collect everything on the left hand side, we get k squared minus 3k minus 10 is equal to 0 as required. In part B, we're asked to hence find an equation for C, and the first thing to do is solve the quadratic equation we obtained in part A for k. So this factorizes into k minus 5 times k plus 2 being equal to 0, which means that k minus 5 is 0, or alternatively k plus 2 is equal to 0. So we've got k is 5 or k is -2. Now the solution of -2 is rejected because the question itself says that k is positive. So this is rejected since k must be positive. And I can therefore proceed by revisiting my diagram. I will update the coordinates of P and Q now that we've got the value for K. So since K is 5, this means that the -1, K plus 8 is now -1, 13. And then for Q, the 3, K squared minus 2K now becomes 3, 15. We've got the full coordinates for both P and Q, and I can proceed in finding the distance PQ, which is simply the radius of the circle. So the radius is PQ, which is going to be 15 minus 13 squared plus the 3 minus the -1 squared, and all square rooted. This gives an answer of 2 root 5, which is the radius of the circle. And recalling that the circle centered at the point alpha beta with the radius of r has an equation x minus alpha squared plus y minus beta squared is r squared, then this means we're looking at x minus the -1 squared plus y minus the 13 squared is equal to 2 root 5 all squared. So we're looking at x plus 1 raised to the power of 2 plus y minus 13 raised to the power of 2 is equal to 20. In question 11, we've got the prices of 2 precious metals being monitored. Now the price per gram of metal A is given by this expression here. It is the number of months after the monitoring began, whereas the price per gram for metal B is given by this equation here. P is a positive constant. We are told that VB is 2VA when T is 0, and we need to find the value of P. So when T is equal to 0, VB is equal to 2 times the VA. So VB when T is 0 is simply PE to the power of 0, and this is equal to 2 times the 100 plus 20e to the power of 0. Now, e to the power of 0 is simply 1, so this leads to P being equal to 240. When T is capital T, the rate of increase in the price per gram of metal A is equal to the rate of decrease in the price per gram of metal B, and we need to find the value of capital T, giving our answer to 1 decimal place. Now these are the 2 equations, the 2 models we're dealing with. Since we are working with the rate of increase and the rate of decrease, we need to consider derivatives. So I will start with dVA dt. So the 100 when differentiated vanishes, and the derivative of e to the 0.04t is simply 0.04 e to the 0.04t. So we're looking at 20 times 0.04 e to the 0.04 t. Now this simplifies to 0.8 e to the 0.04 t. And let's proceed for VB. So dVB dt, it's going to be 120 times the negative 0.02 e to the negative 0.02 t, which simplifies to negative 4.8 e to the negative 0.02 t. Now the negative here indicates a decrease because the price per gram for metal B is decreasing. Now we know that we need to evaluate each of these at small t being equal to capital T. So when t is capital T, dVA dt is 0.8 e to the 0.04 capital T, and dVB dt when small t is equal to capital T is equal to negative 4.8 e to the negative 0.02 capital T. Now we are told that the rate of increase is equal to the rate of decrease. Now the rate of decrease doesn't have the negative sign because the negative is incorporated within the word decrease. So what we are looking at is the 0.8 e to the 0.04 capital T being equal to the 4.8 e to the negative 0.02 capital T. I will proceed by dividing both sides by e to the negative 0.02 capital T. So I'm collecting the exponential term on the left hand side. So we're looking at 0.8 e to the 0.06 capital T being equal to 4.8. And I will divide both sides by 0.8 to arrive at e to the 0.06 capital T being equal to 6. And then if I take a ln of both sides, we get 0.06 capital T is equal to ln 6. And therefore capital T is 1 over the 0.06 times ln of 6. If we plug this on the calculator, we get capital T is 29.9. In question 12, we're given the plan view for the design of a swimming pool. Now the pool is modeled as a quarter of a circle joined to two equal sized rectangles as shown here. Now we are told that the radius of the quarter circle is x meters, the rectangles measure x by y meters, and the total surface area of the swimming pool is 100 square meters. And we need to show that according to the model, the perimeter p meters is given by p being 2x plus 200 over x. So looking at the diagram here, let me add the measurements we were given. So here AB is y, this part is also y, this is x, and this is y. Now this is the quarter of a circle having a radius of x. We know that the circumference of a circle is 2 pi r, so the length of the arc here is given by 2 pi x over 4. And with regards to the area, it consists of the rectangle here, the quadrant, and another identical rectangle as shown highlighted here. So let's start with the area. The area will be given by xy plus xy plus the area of the quadrant, which is pi x squared over 4. Now we are told that the area is 100, so we're looking at 100 being equal to 2xy plus pi x squared over 4. I will proceed by making y the subject, and I will first multiply by 4 throughout to get rid of the denominator. So we're looking at 400 being equal to 8xy plus pi x squared, and therefore 400 minus pi x squared is equal to 8xy, which leads to 400 minus pi x squared and all divided by 8x being equal to y. Now for the perimeter, let's look at the diagram here. It's gonna be y plus x plus y plus y plus x plus y plus 2 pi x over 4. So let me write down an expression for the perimeter p in terms of x and y. We are looking at 4y plus 2x plus 2 pi x over 4. Let me start by simplifying the 2 with the 4 to leave me a 2 in the denominator, and I'll be replacing y with the expression we just obtained through the area. So the perimeter capital P is given by 4 times the 400 minus pi x squared over 8x, we've got the plus 2x, and we also have got the plus pi x over 2. Now the 4 with the 8 will simplify to leave me with the 2 in the denominator. So all in all, we're looking at p being equal to 200 over x minus pi x over 2 plus 2x plus pi x over 2. Now the pi x over 2 terms will cancel out, and therefore we conclude that p is equal to 2x plus 200 over x as required. In part B, we need to use calculus to find the value of x for which p has a stationary value. So when we talk about calculus, we mean differentiation here, and the stationary value is satisfying that dp dx is equal to 0. So let me first write the expression for p in index form. So p is equal to 2x plus 200x to the minus 1. So dp by dx will be equal to 2 plus 200 times the negative x to the negative 2, which is equal to 2 minus 200 over x squared, and we set this to be equal to 0. So we've got 2 is equal to 200 over x squared. I will cross multiply to get 2x squared is equal to 200, and therefore x squared is 100. And if I take the square root, we get that x is equal to 10. In part C, we need to use further calculus to prove that this value of x gives a minimum value for p. So essentially, we need to do the second derivative test here. Let's start with the expression we had for dp dx. We have found from the previous part of the equation that dp dx is 2 minus 200 x to the minus 2. And I will proceed with the second derivative, so the 2p by dx squared. So this is equal to minus 200 times negative 2x to the negative 3, which gives me 400 over x cubed. I will proceed in evaluating the second derivative at x is 10. So the 2p by the x squared at x is equal to 10 is equal to 400 over 10 to the power of 3, which gives an answer of 0.4, which is greater than 0. And therefore we conclude that at x is 10, p is a minimum. Now we need to be careful here. We need to explicitly compare with 0 and write down the conclusion to claim the second mark for this part of the question. Now we are told that access to the pool is by side AB as shown in the figure provided, and given that AB must be at least 1 meter, we need to determine according to the model whether the swimming pool with the minimum perimeter would be suitable. So let's briefly go back to the figure provided. AB is y, so we need to investigate the value of y when x attains the value of 10, and therefore the perimeter is a minimum. So let's start by stating that AB is equal to y, which we found to be equal to 400 minus pi x squared divided by 8x. So when x is equal to 10, we get that AB is equal to 400 minus pi times 10 squared, and all divided by 8 times 10. This gives an answer of 1.07 meters. And therefore we simply state that since 1.07 is greater than 1, the swimming pool with the minimum perimeter will be suitable. Question 13 is on trigonometry. We need to show all stages of our working, and solutions relying entirely on calculator technology are not acceptable. We need to show that this trigonometric equation can be written as a quadratic in tan. So we start with sine theta times 7 sine theta minus 4 cos theta is equal to 4. I will start by expanding. So we're looking at 7 sine squared theta minus 4 sine theta cos theta is equal to 4. Now I will be collecting everything on the left hand side. So we're looking at 7 sine squared theta minus 4 sine theta cos theta minus 4 is equal to 0. And now we know that sine squared theta plus cos squared theta is equal to 1. So I will consider the 4 here as 4 times 1, and I will replace this one with sine squared plus cos squared. So we're looking at 7 sine squared theta minus 4 sine theta cos theta minus 4 times sine squared theta plus cos squared theta is equal to 0. And then I will expand to get 7 sine squared theta minus 4 sine theta cos theta minus 4 sine squared theta minus 4 cos squared theta is equal to 0, which leads to 3 sine squared theta minus 4 sine theta cos theta minus 4 cos squared theta is equal to 0. Now we can see that we've got the right coefficients, 3, negative 4, negative 4, according to the equation we need to arrive at. And I also need to divide throughout by cos squared theta. This will allow the tan theta to start appearing here, because we know that tan theta is sine theta over cos theta. So the sine squared over cos squared will give me tan squared. So we've got 3 tan squared theta. Then the cos theta with the cos squared theta will leave me a cos theta in the denominator. So we're looking at negative 4 tan theta. And the cos square with the cos square will cancel out, giving me negative 4 being equal to 0 as required. In part B, we're asked to hence solve for x between 0 and 360 the given trigonometric equation, giving our answers to one decimal place. Notice that the theta became an x, but otherwise it's the same equation we're dealing with. So I will proceed by factorizing the quadratic in tan. So I've got 3 tan x plus 2 times tan x minus 2 being equal to 0. So we're looking at 3 tan x plus 2 being equal to 0, or alternatively, we've got tan x minus 2 is equal to 0. So I've got 3 tan x is negative 2, which means that tan of x is negative 2 over 3, and the principal value is given by shift tan of negative 2 over 3. I'm gonna go on my calculator. Shift tan of negative 2 over 3 gives a result of minus 33.69 dot dot dot. I will store this on A to be used later. So I write an A here, and we know that when we are solving trigonometric equations involving tan, the solutions are given by x being the PV of A plus 180k, and I will then proceed with tan x minus 2 being 0. So we've got tan of x is equal to 2. The PV now is given by shift tan of 2. So on the calculator, shift tan of 2 gives an answer of 63.43 dot dot dot. I will store this one on B. So let me make a note here. This is B, and therefore we are looking at x being equal to B plus 180k. And I will proceed on the calculator to generate all solutions between 0 and 360. So I press menu, it's option 9. My f of x is A plus 180x. My g of x is B plus 180x. I will start at negative 2. I will end at 5. I'm stepping every one. So all of these are solutions. We only need solutions between 0 and 360. And we can see that the first positive solution is at 63.4. Then I proceed. We've got another solution at 146.3. Then we've got another solution at 243.4. And then the final solution at 326.3. A total of 4 solutions. In part C, we need to hence find the smallest solution of this trigonometric equation in the range of 720 up to 1080, giving our answer to one decimal place. It's exactly the same trigonometric equation. However, instead of x, we now have 4 alpha. So I will go back to the generating formulae we obtained in part B, and instead of x, we're looking at 4 alpha being equal to A plus 180k, and 4 alpha being equal to B plus 180k, which means that alpha is A plus 180k over 4, and then alpha is B plus 180k divided by 4. So I'm gonna go on my calculator once more. Menu, option 9. My f of x is gonna be the A plus the 180x and all divided by 4. And my g of x is gonna be B plus 180x divided by 4. I can start at -2, go up to 5. Let's see what kind of solutions we get. Remember, we're trying to find the first solution after 720. So if I scroll down, I can see that I go up to 195, 240. As I can see, I can change the number here. If I keep pressing the equal sign, then the x keeps increasing by 1. So if I keep doing that, I want to see the first time I go over the 720 mark, which is obviously here. It's 735.9. So we conclude that alpha is 735.9 degrees. Question 14 is on proof. We need to prove using algebra that n squared plus 5n is even for all n in the naturals. Now the naturals are the positive integers. Before we present the proof, let's be clear here that if you use a logic approach, you will score 0 because the question is asking for you to use algebra. So with the logic approach, we mean that someone could say that if n is even, then even squared is even, and then 5 times an even number is also even, and then even plus even is even, and so on. If you do something like this, you will not be scoring any marks because the examiner here expects to see algebra. So I'm gonna use proof by exhaustion here. I will divide all the natural numbers into the odd and the even, and I will start with the even numbers. So I say consider n being even, so consider n being 2k for some k in the integers. Then we've got n squared plus 5n being equal to 2k raised to the power of 2 plus 5 times 2k, which gives me 4k squared plus 10k. I can see that I can factor out the 2 here, so we're looking at 2 times 2k squared plus 5k. And since there is a factor of 2, we certainly conclude that this is giving me an even result. And then I will proceed with considering n being an odd number. So I'm going to say consider here n being equal to 2k plus 1, where k belongs to the integers. Now n squared plus 5n in this case is going to be 2k plus 1 raised to the power of 2 plus 5 times 2k plus 1, which gives me 4k squared plus 4k plus 1 plus 10k plus 5, which simplifies to 4k squared plus 14k plus 6. I will factor out the 2 again, so we're looking at 2 brackets 2k squared plus 7k plus 3. And once more, since I could factor out the 2 here, we also conclude that this is giving me an even result. And therefore, all I'm missing here is an overall conclusion to complete the proof. So I say hence n squared plus 5n is even for all n in the naturals.